adding, we've done subtracting, next is multiplying. So how do we multiply a polynomial? In this case, we're just going to multiply by a monomial. Let me show you. But before I actually do that, remember how you find the area of a rectangle? Like if I did like 3 times 4. Yeah, that's like having 3, right? There's 3, and then 4. 3 times 4 is 12. Same idea here, okay? I'm going to ask you to use algebra tiles first to visualize the multiplication, and then we'll generalize this to the algebra. I'm going to ask you to place the term in front of the bracket on one side of the chart, and I'm going to show you what I mean by the chart, and then the other polynomial on the other side, and then you're going to fill the chart with the tiles that the product creates. What do you mean? Let me show you. So here's our monomial 2, and here's our polynomial 2x. So the 2 I'm going to represent using algebra tiles, and yeah, that's just the 2 small squares. And the 2x, well, that's just the 2 rods, right? Rod and a rod. Now notice how the shorter side of the rod, that length is equal to the length of the small square. So when I multiply, my question is this. Let's fill in the tiles in here, all right? So if I take a rod multiplied by 1, I'll get just another rod. A rod multiplied by 1, the rod. A rod multiplied by 1, I get another rod over here. And a rod multiplied by 1, that's another rod. So our answer is really in this area here. So what's my answer? My answer is 4 rods, or 4x. So here's my statement. 2 times 2x, that equals to my answer, which is 4x. Okay, let's do another one here. Here I got -3, so let me draw now 3, but I'm going to have 3 shaded squares. So 1, 2, 3. And then I have 2x minus 3 as my polynomial, so 2x once again, a rod, a second rod, and then minus 3, so 3 shaded squares. Alright, and once again, our answer is the stuff over here. We're going to actually now combine them together. So a rod times a -1 gives me a rod as a shape, but what color should it be? Positive times a negative is a negative, so this should be shaded in. So a negative rod. Same thing down here, another negative rod. Another negative rod. Positive rod times a -1, that's a negative rod. Negative rod. Negative rod. And ultimately over here, -1 times -1, that's a positive 1. So a positive 1 small square, positive 1 small square, positive 1 small square. We'll do the same thing over here and over there. So when I ask you now -3, and I'm asking you to multiply that by 2x minus 3, the result is what you have here. I see 6 rods that are negative, and I see 9 tiles that are 1 unit that are positive. And there's your answer. Okay? One more for you, please. This time I'm going to ask you to do 2x. So notice I've already drawn that for you. Here's my 2x. And then the 3x minus 5 is just up top. Can you now go ahead and draw in the area to find the product? Well, rod times a rod, that gives us the large square. Another large square. Large square. Large square. 2 more large squares. Alright. Okay, a -1 times a rod, that just gives us a rod, but now it's negative. 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 Negative, negative. 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 Ta-da. Done. So, our answer will be 2x multiplied by 3x minus 5 gives the result, or the product of 1, 2, 3, 4, 5, 6. 6 large squares, that's 6x squared. And then 1, 2, 3, 4, 5, 6, 7, 9, 10 minus 10x. So of course we don't always want to do the algebra tiles, but I want to show you one more way of representing it. I know that this time we use this little chart, but we can also think of it in terms of groups. I like the chart method, by the way, more, and I'll show you why in the next video. But right now we can think of it as groups as well. The 3 could represent 3 groups of the 2x plus 4 tiles. So how would that look? Well, my first group of 2x plus 4 would be this. I want 3 groups, so 3 copies. And so how many of each do I have? Well, I've got 6 x's, and I've got now 12 small squares. Okay. So ultimately now, with both those methods, can you see a pattern here? Okay, whether using the chart or using this group idea. Can you see that what you need to do is take the 3, and that 3 is multiplied by each of the terms in the polynomial. 3 times 2, right? 6x. 3 times 4 is 12. Even on the previous page, look. Like here. Negative 3 times 2, that's negative 6x. Negative 3 times negative 3, that's positive 9. Same thing here. Look. 2x times 3x, that's 6x squared. And then 2x times negative 5, that's negative 10x. So the idea here is the following: to multiply polynomials by a constant algebraically. Use the distributive property. I wouldn't even say constant, I would say a monomial, okay? Because it doesn't have to be just a number. It could be just one term. We distribute it like this. We take a times b, and we write down ab. And then we take a and multiply that by c, and we get ac. And this tells you to distribute each term within the brackets by the term that's found outside the brackets. Okay, so let's try some examples, and then we're done today. Determine each product without drawing algebra tiles. So the idea here is we take the monomial or the constant and we distribute it into each of the brackets, or each of the terms in the bracket. 4 times 3a, that gives us 12a's. 4 times 2, that just gives us 8. That's it. Same thing here. 3x now, so 3x times 2x, so 3 times 2 is 6. X times x, that's an x squared. Okay, and then 3x times negative 8, that's negative. 3 times 8 is 24, so minus 24x. That's it. Okay, let's try C. Same idea. Don't freak out if there are more than 2 terms. Same idea. So 2 times 4 gives you 8, so 8c squared. 2 times negative 2, that's negative 4, so negative 4c. And then 2 times 3 is 6, and that's your final answer. Now what about this one in part D? It looks like the monomial is at the end. No worries, do the same thing, just distribute like that. So I'm going to do negative 3d times the d squared, that's negative 3. D times d squared, so think about it. D times d squared. Back to your exponent days, and that's like d, and then d squared is dd, so there are 3 of them. That's d cubed. And then similarly, negative 3 times 2, that's negative 6. D times d is d squared. That's it. Okay? So, I'm going to let you try E and F. I don't want to speak it to you, because I think you can do it now. Try it yourself. Pause the video. Then restart it when you got an answer to double check it's the same as mine. Okay? And if it's not, by the way, make the corrections. But if it is, give yourself a pat on the back. Use that cube again. M times m squared is m cubed. M times m is m squared. And then 3 and 7, that's 21. M. Lots of m's.